Okay, so we've looked at the input channels. Now let's have a look at the output stage. There are 2 power amps inside here, and there are 5 different ways that we can use these power amplifiers. The LEDs here tell the story. At the moment there's a green LED next to left and a green LED next to right. That means that it's operating in stereo mode, so left and right. Down here you'll notice that the LED is not lit, and that means that this mono sub-socket up here is acting as a mono output. That's line level. So if we needed to feed into a house system at a particularly large venue, then this simply sums together our master left and rights and passes that straight out to the front house system of the venue. Now if I press and hold the power amp mode button, what you'll find is that this LED now comes on. That's now converted our mono output to being a sub output. Now all the frequencies below 100 Hz are routed through this socket, enabling us to plug it into a powered sub or into an external power amplifier and then into a pair of subs. What it's also done, and this is something I've found to be unique to this powered mixer, is that it's actually removed all the frequencies below 100 Hz from the 2 internal power amplifiers. So that means that it's acting as a real active crossover. That now means that we don't have to ask the internal power amplifiers to cope with those ever-demanding low frequencies. Instead, they're going to be handled by a source outside of the actual powered mixer. So now if you think about it, by putting a large power amplifier just dealing with low frequencies outside of the powered mixer, 600 watts per channel purely for mid-highs turns it into quite a substantial system. Okay, so we press the power amp button once more. What now happens is amplifier 1 is being fed from monitor 1 and amplifier 2 is being fed from a mono sum of our left and rights. Because the powered mixer also knows that we're going to use amplifier 1 for monitors, it introduces a 75 Hz high pass filter to the output of power amp 1. When you put a loudspeaker on the floor, we get an increased amount of low end from it. We don't need that to mess up the efficiency of a power amplifier. So it automatically filters out those low frequencies without causing us any problems with our monitors. Also, you'll see that the LED is not lit on our mono sub output, so our socket here is simply a mono left and right sum. However, press and hold the button once more, and now what happens is all the low frequencies below 100 Hz come out of this socket here, and all the frequencies below 100 Hz are removed from our main amplifier on channel 2. Let's push the button once more, and now what we find is that amplifier 1 is being driven from monitor 1 and amplifier 2 is being driven from monitor 2. So now our internal amplifiers are only driving our passive monitors. That leaves us our signal level line outs, left and right, to feed into our external PA system. Particularly useful if perhaps you're using an active system, but you still have passive monitors. The graphic equalizers in the XR1212 are what we call constant Q. That means that they're ideal for being able to equalize a room. You know, sometimes you turn up to a venue and the system feeds back or just doesn't sound right. Well, a constant Q graphic is what's going to help you to fine-tune the room and eliminate that feedback. Most other powered mixers out there in the marketplace only have what we call a non-constant Q or a variable Q graphic. Problem with those is they're great for making tonal tweaks to things, but if you need to actually eliminate a peak within a room that's causing feedback, they tend to take a lot of the program material around those frequencies with it. Each of the graphic equalizers is assigned to the internal power amplifiers. That means that no matter what function we have the amplifiers performing in, the graphic is always assigned to that power amplifier. After the graphic equalizer we have something called AutoEQ. This is a clever little function because it enables us to automatically equalize the system for whatever room it's performing in. Here's how it works. You take a standard dynamic microphone like an SM58 or a Peavey XR1212, something like that, and you plug it directly into the real-time analysis input, the RTA input. That microphone then gets put on a stand roughly about 10 feet in front of one of your loudspeakers. Next, we set up a nominal volume for whatever live vocal mics that we have in the system. Let's say, for example, we've started with our RTA microphone in front of our left-hand speaker. Press and hold the AutoEQ on the left channel. What the system will now do is automatically turn these 4 channels up until they start to feed back. If they do feed back, it will input 2 very fine notch filters to eliminate any feedback that may have occurred. After it's finished that process, it will then put a burst of pink noise through the left-hand channel of the amplifier. This noise is heard by the microphone that you've placed in front of that loudspeaker, and the onboard DSP analyzes the signal and determines that if there are any peaks left in the room, it will filter those peaks out. Once you've finished with that channel, you move your microphone over to the right hand side speaker and press the AutoEQ button again. The system will go through the same process, and then you'll have EQ'd both sides of the PA system. As belt and braces protection against feedback, once you've EQ'd the room, you also have something called feedback ferret. This is an automated feedback suppressor, and you activate it by simply pressing and holding this button until the lights correspond to which channels you would like to have feedback ferret on. Okay, so that's our output stage. Below that we have our effects processor. Now, one of the most common demands upon effects processors these days is to have something as simple as an amount of reverb and an amount of delay, and the ability to balance those two things out. The way Peavey's done that on this particular unit is we have something called parallel effects. And for example, on P1 we have a parameter control. The parameter control enables us to effectively seesaw between more delay and more reverb. In addition, we have a tap tempo button. This enables us to get exactly the right tempo for the song and then dial in however much reverb we want versus delay. Of course, it's got other stuff in there as well, things like straight reverbs, chorusing, straight delays, and a number of other effects as well, which are all viewable in the manual. So there's lots of effects to choose from, and they're high quality too. On the top of the console here we have a foot switch socket. Now you can either use a standard foot switch with one button, which will mute the effects, or if you use 2-button foot switch, one of them will mute and the other becomes your tap tempo. You can use any foot switches to do that, as long as they're momentary foot switches. Finally, after we've been through all that processing, we come to the internal power amplifiers. Each amplifier is rated at 600 watts and uses a Class D technology, which makes it very lightweight and very efficient. The other advantage is that each amplifier has 2 combi speak-on outputs, and that's a speak-on connector and a jack in one. So if we're running the system in perhaps main mono for channel 2 and then monitors from channel 1, it does enable us to plug 2 cables into each power amplifier to ensure we don't have to do lots of daisy chaining. That's a fairly in-depth overview of the Peavey XR1212. Thank you for watching, and I'll see you again.